Okay, we're going to go for A3 in Appendix A. Appendix A is toward the end of the book. And to demonstrate, if I show you let's see, one of my students gave me the book. Thank you for the book. I didn't have it. So if you go to the appendix is more on the end. If you scroll down, open the book, and go to Appendix, and we're looking for Appendix A, and you can move in order. That's A1. The pages, if you notice up there, the pages are A2, right there. If you go down, A3, 4. So we're talking about Appendix 3, that's 2. Appendix 3 right there on page A13. Alright, toward the end of the book, look in there and you would find these problems that I'm going to talk about. They're right here. These problems. So, in Appendix A, toward the end of the book, we're going to do 2 reviews. Maybe 3, depends on how much time we have. So first we want to review exponential properties and radical properties, and here they are. So keep in mind, any number to the 0 power other than 0 is 1. Negative powers, they always move. This is crucial for us to really get things going. You could take a radical and write it as an exponential power. Oops. Not that. That. And that. Now, if you don't see anything sitting on a radical, there's always a 2 sitting there. That's called a square root. If it's anything other than that, they have to say it. When you multiply 2 terms with the same base, you write a single base and you add the powers. When you divide 2 terms with the same base, you subtract the powers. If you raise, you end up multiplying the powers. One key element that's not in here, if you take x over y and you raise it to the negative n power, if you see a negative power and a fraction, you could switch the negative to a positive by taking the reciprocal of those. And we're going to play with this. I'm not sure how much you remember, so this is kind of a quick review of a few topics. I picked those 3. Again, we're not going in full heavy duty on those because we're just refreshing the memory of what you need. If I take number 2, and the expression is really x squared over 3. If I take x equals 6 and throw it in there, that would be 6 squared over 3, and that is that's 36 divided by 3, which is a 12. And if I take the second, number 14, and I say add x to the negative 3/4, and if x equal 16, I'm going to say this is 16 raised to the negative 3/4. Negative powers, we always move. You have 2 options. Either you're going to say this is really the 4th root of 16 cubed, and in turn you're going to say this is 1 over, this is 2 cubed, that's an 8, or you're going to say this is 1 over 16 is 2 to the 4th, and when you raise powers you multiply, and that would be 1 over 2, 4 times 3/4, they cancel out, and that's 1/8. Either or. And if I take number 20, 6 root of x, and if x happens to be 325, then I'm looking at the 6th root of 325. And if I take 325 and I break it down, 5 divides 36 times, and 5 divides 25, I'm sorry, yeah, 5 times, that's 30 and 25, 5 times. 5 divides 1 time, and you have 1 left, 13. So that doesn't really simplify. It really doesn't clear the radical. That simply stays at, what, 25 times 13, which there's not much you could do about that. Or you could just leave it as the 6th root of 25. We can't always simplify everything. If I look at the next set of problems, simplify the expressions. Well, this is what we do. Negative powers, we always move. This is going to move to the denominator. And this, isn't this 3 squared? Isn't 3 squared 9? And when you raise those, don't you multiply 4 times 2 is 8? Wouldn't that make this 81 x to the 8 over z, oh, cubed. My mistake. No need to squish things down. We have plenty of space. Here we go. And if I look at number 28, say, all right, well, let's see how 28 works. This is actually, it'll be better if you simplify from the inside of the parentheses out. Divided by 3, that's a 3. Divided by 3, that's a 4. One of those cancel with one of those, you have s left. And isn't this saying, this is 4 cubed, s cubed over 3 cubed. 4 to the third, 4 times 4 is 16 times 4, that's 64 s cubed, divided by 3 times 3 is 9 times 3 is 27. And the last problem, I'm looking at the 4th root of 32 xy to the 5th divided by z to the 8th. Now, how does this work? 32 is 2 times 16. 16 works well because 16 is 2 to the 4th. So that 16 clears as a 2. X, not much you could do. And you have 1, 2 left. How many 4s are there in 5? 1 and 1 left over. And 4 divides 8 how many times? 2 times. So my answer is 2y, the square root of 2xy divided by z squared. So again, this is a bit more on and off really what you need, but this part is a must. This is very annoying, but you need to get that out of the way. Factoring. We are used to seeing this, and I'll elaborate with you on what needs to be done, not to worry. If you want to factor, you look for the greatest common factor, that's a 2x squared. And now if you take 8x to the 4th divided by 2x squared, that's 2x squared. Negative 6x squared divided by 2x is a negative 3. There it is. Now, I want to add a problem. I want to take a problem and throw it in there. An extra problem on top of what you already have to do. Yeah, I know. You're thinking as if you don't have enough. Well, let me show you. If I was looking at 8x to the 4 thirds minus 6x to the 2 thirds, notice those are the same. And notice those are the same. Ignore the thirds. Take 8x, I'm sorry, not 8x, 4x, 2x to the 4th. Now ignore the 3 completely. If you take 8x to the 4 thirds divided by 2x to the 4th, that is just, I'm not doing anything right, am I? If that was a 2, we'll take a 2. So 8 divided by 4 is, 8 divided by 2 is 4. X to the 4th divided by x squared is x squared. There it is. Minus 6 divided by 2 is 3. X squared divided by x squared is really no x at all. That's really cancels out completely, right? And now what you do, you say, all right, now take care of that third, divide this by 3, divide this by 3, and there it is. And that's how you factor those. If you follow the same trend, and let me show you really quick, you look at a problem like 42 and you're thinking, oh my god, where did this come from? Well, believe me, it's the same thing. Look at the 3 terms. I see the 2, the x. I see an x minus 1 to the 9. I see an x plus 4 to the 2nd. I see a 4, an x minus 1 to the 5th, and an x plus 4 to the 5th. So if I want to take the greatest common factor, I'd say it's a 2, x minus 1. If I look at the 9 and the 5, I'll take the 5, the smaller. And x plus 4. If I look at the 2 and the 5, I'll take the 2. And let's see how this works. If I take this divided by this, 2 and x will be left. Now, when I take this piece, this, it didn't register. If I take this divided by this, if I take 9 minus 5, I will get a 4. And if I take this divided by this, I'm going to get an x plus 4 for sure. If I take 2 minus 2, they undo each other. They're gone. Right? So it's as if there's nothing there. Okay, very good. Minus. When I take now this divided by this, 4 divided by 2 is a 2. When I take this divided by this, I will get, actually that will cancel out because 5 minus 5 is 0, that's gone. When I take this divided by this, I'm going to get an x plus 4, and if I take 5 minus 2, that's a 3. Now, you come down and say, wait a minute, there was a denominator of 2 on those, so divide this by 2, divide this by 2, the yellow. And there was a 3 on this. Divide this by 3 and divide this by 3. And do you see what happens? Again, it takes a bit of practice. That's something that we do need. X minus 5 to the 5 halves, x plus 4 to the 2/3. Notice what happens. Isn't that x minus 1? 4 over 2, isn't that a 2? And 3 over 3, isn't that a 1? All what you have to do is clean up the last piece and you're done. The goal later on is to figure out where this equals 0, and that's really what it takes. And that is x squared minus 2x plus 1 by x, that's x cubed minus 2x squared plus x minus 2x minus 8 and that doesn't factor. This is as far as you go. Alright, a couple more to go. If I wanted to simplify this problem, again, I'm doing as much as we need, and we need to get this much. If I take number 44, it's not as bad as you think. I have two options. I could look at the top and say, look, I'm going to factor out an x minus 1 squared. I noticed that this is common in both, and I'm going to take the smaller power, which is a 2. And that's going to leave me with x plus 1 minus, and that will be x minus 1 divided by x plus 1 squared. And all what I have to do is clean that bracket and I'm done. It looks a lot worse than it is. That is x plus 1 minus x plus 1. That is 1 plus 1, that's a 2, into x minus 1 squared over x plus 1 squared. And that pretty much takes care of that. Oops, no arrow. And if I take this problem, again, something that doesn't leave us alone. Here, we're dealing with negative powers if you ignore the 2. If I was looking at 5x to the 3 halves minus x to the negative 1 half, well, the common is x. If I have x to the third and x to the negative 3, I'll take the smaller. We always do. And that would be what? X to the third divided by x to the negative 3, that's x to the 6, and a 5 minus, and this is disappearing. Since there's a 2 in the denominator, I'm going to divide this by 2 and this by 2, and there's a 1 there, and that leaves me with x to the negative 3 halves into 5x cubed minus 1. Another way of doing this problem. Again, if we didn't need this, I wouldn't be covering it. You really need it. Another way of doing this problem is for you to say that's 5, the square root of x cubed minus 1 over the square root of x cubed. Simply get a common denominator. The LCD is x cubed. You multiply this by square root of x cubed top and bottom. That leaves you with 5 square root of x to the 6 minus 1. And we all know that square root of x to the 6 is x cubed, which is pretty much this. Again, you could do that too if you wish. I don't mind. They say factor, you don't have to. The last part that we have to deal with in this section is simply domain. If you see an even index radical, you take the quantity underneath the radical and you set that to be bigger than 0 or equal, and you solve it, and that's pretty much it. Something again that we're going to have to do. When you divide by a negative, you switch the sign. So we know already on a number line, 5 halves included, x is less than, so negative infinity to 5 halves would be my answer. And the homework is listed right there. And that concludes this section.